So here we are back again with part 2 of the dance step DSP, well, discrete sequence performance task. And now we're gonna kick back into E prime 2, and we're gonna look at the script in detail, right? So in here, open, and I'm gonna go into skip out of that. Let's see. So my computer is a little bit slow, but should be fine. In here, and scripts. There we go. Practice. There. Right. So opening up as well. So earlier in the part 1, I explained how the script looks like and what is possible as inputs. As I said, you can make things as complicated as you want to. You can put in 12 key steps. You can put it, but for us, our goal in what we call the DSP task, the discrete sequence performance task, is to give people two separate sequences, quite distinct ones, of about equal difficulty, and then as each participant takes place, right, we shift around. We call this process counterbalancing, but we shift around the positioning so that it starts on a different position for each participant, so that there's no self-standardized effect. It's the same sequence, but it gets shifted around every sequence based on the positioning of the starting, right? So let's say if they were meant to, if participant 1 starts from the top one, then participant 2 will start from the right, participant 3 will start from the third below, and participant 4 will start from the left corner. But the sequence itself remains the same. It's just a shift of the positioning. Now, what this happens and why we do this is because it's essentially a way to prevent that there's some sort of feed-related sort of response effect, or that there's a preference because of the way the positioning is laid out, that this effect is consistent across one of the sequences but not across all of them. So we do this to sort of balance it out with everyone, right? So once you have the sequence, as I said, right, allow collapsing, and you can what we call the header of the experiment is over here. It's called stepping task, and once I spider down, you can see that there are a lot of different components that made up what was going on in that relatively simple experiment. Now each of these ones with what we call, these are the basic units within E prime itself. They all represent different procedures. Okay, cue procedure, fixation procedure, a response procedure, a feedback procedure, in which you saw as well. So they're the bread and butter of it. Now within a procedure, it's like specifying loops within it, right? So you're trying to understand what you're trying to make your participants do a certain behavior, and then present them with a certain number of cues for them to respond. And after they respond to it, in the background of these, you're capturing essential information such as response time and accuracy, which you saw in the experiment, that it tells you when you made a mistake, what is your percentage of error, and things like that, before they complete and kick out of the experiment itself. Now, some of these instructions here, you may notice is fault. They're still in Dutch, unfortunately. This script originally was written in Dutch, and then especially the elements in it, the elements, especially when you define them, they're in Dutch, and I don't want to mess around with them too much. And because each of these point towards certain objects, and if you look at the whole script, right, maybe in E prime 3 is a bit easier, but in E prime 2 you have to manually change all these objects as well. If you change one name, if you change it to English and say fault 1, then every other line that contains this that points towards fault 1 will have to be changed as well. So it's a bit tedious to do so, but once I leave the script with you, you can do anything that you want or update it as well. But however, the instructions inside it, we've tried to comment it out as much as possible to provide you with the keys of instructions. As you can see, it's quite simple in its essence. It's saying enter a session, right? So this is a session itself, and within the session, we want them to be performing a certain number of sequences, right? And so I'm just going to focus on each of these broad elements first. Within the sequence, there's firstly a queue procedure. You remember when it was flashing, right? That is a queue procedure in which they're shown a certain number of queues in there. We're going to go into those items later on in a little while. Then there's this fixation procedure in which it goes whether it's red or blue, right? So the fixation procedure is like get ready, go, right? The blue would be a go, red would be don't go, stay put where you are, and wait for the next trial, right? So within the fixation procedure, it will run a number of times in here, and if it's a go, it continues on to what we consider a response procedure, right? A response procedure is to collect the responses from the participant itself. Once you've collected the responses, then it's time to give them some feedback. You saw all these screens earlier, and when you actually run the script itself, it shows you all these things as well. So if you run it and you do something and then you change it and you come back again, if you don't change too many things at one time, you can see the effects of your changes within the script itself. So this whole thing is what we call the sequential procedure, sequenti procedure. It's in Dutch, and that's what it does. So it repeats this. We want it to repeat this a number of times of 48, but then every now and again, it goes to a no-go procedure, right? It taps onto, in this sequence itself, right? In the session proc procedure, it taps onto another thing, which is the go or no-go in here. So the no-go procedure would be to say that, right, in the red, what happens, and then there's a fixation procedure again, and there are a certain number of labels here in which I would not touch these labels if I were you or anyone else that's doing this, in which there are key points in which the script kicks them towards, not kick, but brings them towards. All right. So let's go into each of these elements as well. So now there are also at the end of it, you can see how in the session proc, within this, it shows you the line here, and it shows you how many elements are being binded to that whole line, right? So in here you can see that in the session proc itself, within the experiment, almost everything that we do in here binds towards this entire sequence 1, sec 1 here. Okay. Now let's go through each of these elements here. So when you go in experiment, all right, it says there's an author, and we can put in a bit more. Currently curated by Russell Whaley Chan, U20. BMS faculty. All right, so I'm going to apply that, and that's it. I will have a methodology paper coming up in a little while, and I hope that when you publish your work and stuff like that, you can cite that paper as well for the entire procedure and what we've been doing in here. Now, this is very important. Right? How did I get to here? Here in the experiment itself, it's very important to show what sort of information. Remember, we wanted a subject ID, so we never really collect the real name of people. We we assign them a number and we collect them, and then the session itself tells us the block, what they're practicing, right? And this is the logging level. And here's the one of the most important things. So once joy to key is being integrated as a part of the keyboard, then you need to at least add a keyboard in here, right? Joy to key maps out those keys in which what is needed for interaction with it, which is W, S, A, D, up, down, left, right, W, S, A, D, up, down, left, right. And then space bar is also considered X on as a way to proceed on as well. I think the joypad itself has more than 8 keys, no, has 8 keys at least on there, so you can map out more keys if you want. X0, the triangle, and the square, like the PlayStation board, but it gets more and more complex. So here we are only using 4 keys plus the X as the keyboard. Timing, not really needed. Some other packages that may be needed. e'Prime3 would deal with these a lot more in reality, right? So once this is done, we click OK. In the session proc itself, it tells you what happens. This is something like PowerPoint. It tells you the number of slides in which it will go through before it goes to the end. So each of these blue things are a slide, right? So instructions in line 1, instructions, go to label 4, set a variable. There is a list in which you have to run through. You're gonna look through them soon. You can see block list 1, they correspond. More inline text, feedback, pause, another slide, 3, 2, 1. Remember we had that break in there. More inline, a label, feedback 2, and then we end. So this is the entire block of what is happening. All right. Every one of these corresponds to a certain object within the entire procedure over here. Let's look at inline 1. Right. I'm just gonna very quickly go through this. Otherwise, this whole video is gonna take forever. But oh my God, it's already 12 minutes. So I'm trying to end it like on 20th or 25 minutes max, because it's going to take a while. And you guys can scroll through to different portions to remember what I was saying. So each of these inline text says instruction. Don't worry about this one, MVP. It's a way in which we're sending external markers out to other equipment as well. When you have a apostrophe in here, that tells us it's a comment. So if you do some real coding in an inline, this is what happens if you blah 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 blah. But if you put a comment there, all right, this is putting a comment, and that would render this line not readable by the computer. But for you, it's a way to make some notes saying this is as I said in here, it signals the start of the experiment, right? Right. This is one of the inline codes there. You can open any of these things by double clicking on them, right? So if you go to label 4, label 4 is just an indicator at the point in which the script wants to run to. Now, some of these are definitions. So faulten, we're setting the fault number to 0, and reaction time is a summation, right? And D is also a variable. D is the position in the sequence. It determines which squares to light up. So we've commented as much as possible what's going on in here for you to go through. Now, this is a definition as well. So this is a variable in which it's called until loops, and it indicates the amount of sequences that are shown per half a block. So we want the loops to be 24. If you want it to be 12 times that's being shown, you just switch it to 12. And then the until loops Karen per W. W is a definition as well, and it's defined earlier, and I wouldn't change any of these. All right, just be noted that it indicates how often each sequence is to be shown per half a block. So here we do 24, and you divide until loops by 2 because I want a balance of each of the sequences to be shown equally. So each of sequence 1 and 2 have to be divisible in order that each of them are being shown only 12 times. So if you don't do this correctly, then the number of sequences that are being shown could be unequal. You could have 13 and then 11 on 1 if you don't do this correctly. So here is 12. I want 24 shown, and until loops divided by 12 means in the loop itself, H loop 1 and 2, they will be shown equally, 12 between each of them. Okay. These are variables H1 to 4. We have not in this script been using H3 and H4 loop at all, because H4, H3 and H4 means that there are 4 sequences that people have to learn. But in this script itself, there are only 2 sequences, okay? And as indicated, these variables are used to count the number of times in which a sequence has been shown. They are resetted to 0 every time a block starts itself, okay? Now, this is to set the canvas, the background itself. This is consistent, and it indicates the width and the color of the lines that are used to fill the different 4 shapes as well. Background is black, and the outside squares, they're all silver in color. The fill color, all right, at the start is black, but then when we indicate that when they're being flashed, they will be shown yellow. Right, let's move on. The next one is to have a list, and the list itself shows we want to run sequence 124 times before it kicks into queue list 2, right? And queue list 2 times. And this total specifies that one cycle of this is 26 samples, right? So as I mentioned, we want NoGo trials to come up 2 times, right, in this half a block, and then another 2 times in the second half of the block, which makes 48 trials and 4 NoGo trials. 48 and NoGo, 4 NoGo, right? All this is a little bit complex at the moment, but you get the hang of it when you start to see. Queue list 1 is to show the squares, blank squares, just once every time it runs through this. And this is also a procedure where it points to it. So this list takes cue of the procedure. So this is also an object in here, like that. So the key thing here is when it kicks into this procedure, the sequencing procedure, is to show and flash to the participants what's going on. You can see it's highlighted now, that this one sequencing queues. I put in English that some of these, the instructions were in Dutch, but then H and W indicate which sequence is being displayed. And there are 4 combinations of H and W. Each combination represents a sequence. And of course, the NTAL Karen indicates how often the sequence should be displayed, and it matches them. Okay? And it tries to match between sequence 1 and 2, randomize them, and then you're telling the script to loop them until it reaches 12. All right. If a sequence is shown enough and is true, then it stops, and only the remaining sequence can be drawn. So it could be random that all the way up to the last one, it could be 3 sequences of H equals 2, because all of H1 has been shown 12 times already. All right. So this is what happens to it. Don't worry about these lines. These are write port lines to other external hardware as well. Okay. In the list 2, this is where you determine how many of the queue procedures are being shown. So this is quite important, in which if you want to increase the number of items in there, they go 7, 8, 9, right? And it changes accordingly to what you want it to be as well. Fixation procedure remains at 1, because that's only being shown once. And of course here, the next one, as we run through each of these in tagging queues, right? There's 2 things. So tagging queues is showing what is the sequence itself, all right? And if I'm not wrong, all of these are specific positions relating to each of the positions 1 to 6 itself, right? So, oh, gosh, I can't remember for now, but which numbers indicate up, down, left, right? Because the response procedure is WSAD, right? So that's I'm sorry, but I can't remember from the top of my head. I wrote it down somewhere in my other notebook, in which I don't have it with me right now. But I'll write in the email like what these numbers mean when they're flashing, when they're being shown, right? Each of them correspond to up, down, left, right in here as well. And as I said, if you want to program, let's say a seventh position, then H represents the sequence itself, D equals the 7th position, then B equals to the next sort of, is it up, down, left, or right, and you put in the number correspondingly like that. All right, and of course if this changes, then the earlier part of the script will have to change as well to show that you're going to show 7 positions instead of 6. Okay, now, so two sequences, H equals 1, H equals 2, they're shown by different representations. And then D indicates the step of the sequence is reset to 0 at reaching 7 because we're only using a 6-step sequence. Okay, so this has to change accordingly. So if you're using 9, this becomes a 10, D becomes a 10. If you're using 8 item sequences, it becomes a 9. All right. Then 4 squares are drawn, one of which is colored determined by B. Right, so B indicates which one of them should be drawn. Now, it's different why the numbers and letters is because here we don't need someone to respond, right? Here it's just flashing, and this is why this part of the script is using numbers. And all these are the position of the squares on the pixels itself. So 297, 297, 247, 237, these represent the left and right ones. This is probably the right, this is the left. You can see how the number increases based on the sequential increments. And then this is the bottom square, and this is the top square in here, based on the vertical, and this is based on the horizontal, I presume. It could be the other way around. You can just play around with it and check as well. Then there we go. Okay, so I presume that you can decipher this as well. 0, 1, 2, and 3. This is probably, I'm gonna make an informed guess here that this is going to be, because it's 297, 297 horizontal and vertical. This is going to be left. And then this is going to be right. I'm commenting it out. So number 2 would be lower, down, and number 3 is up, if I'm not wrong. I could be right or wrong, but I'm going to double check this and of course update anyone. Again, don't worry about this. This is writing ports to an external device. Again, this is also not too important in here, setting attributes. Now, let's save this. I'm happy to save that. If you make changes, close it. And then move on to the next part, which is your go or no go. 8 squares are drawn. This is a fixation page. If you look at go or no go, the fixation here is shown for 1500 milliseconds. So I wouldn't change any of these timings at all because they're all fixed for a reason. And sorry, what I meant is here, these frames here have a timing to them, so you can actually change them. But like for example, here it's being shown as a duration 1500 milliseconds, which is about 1.5 seconds. But they're all there for a specific reason, for a specific timing as well. I wouldn't change any of these. So if we keep closing or we keep opening up another one, no response is good, then no feedback, right? If there's a response then too early, and then show the keyboard again, right? So if you made a mistake here, then it's gonna go to this item, Torvik, too early. Torvik means too early, basically. If you pressed it, it goes to this unreferenced item, and then before it runs it, and it kicks it back to label 3 again. So the first label 3, which is here. Okay, so you're starting to get a hang of it now. You start getting a hang of it that when you do certain things, it kicks it to other areas, and the lines are actually quite intuitive in terms of where it goes and what it does as well. The key thing I would say is you want to amend and change. NoGo is this, right? And so if you run through each of the script lines, things that say write port, don't worry about it. MDP commands write string, don't worry about it. Or write port HE010, onset port, all these, don't worry about it, because it's all sending code to other devices that I usually hooked up in my setup. Like I have another 2 or 3 different devices in there that are recording other variables like brain changes as well as the foot movements as well. Another inline tool here, write string, don't worry about it. Right. So essentially, these are the most, after the fixation procedure, sorry, I skipped ahead and I jumped somewhere else. After it's being shown, after certain things are being shown, right? After the stimuli is all being shown where you need to go, then this one is the most important, which is the GIFCA. GIFCA is a collection of the responses. So we're collecting responses here, and for H1, this is where the letters come in because we define the joysticks. Joy the key define the letters in which we are needing to collect these responses, or they need to respond to it. So when I was pressing on the keyboard WASD, this is all being shown here, what needs to be collected. And when you export the data set, they actually match. So you can have key press accuracy as well. So where they made, this is all being captured in the background. In my work, I'm not so concerned about each individual key press, but I'm concerned about, of course, the entire sequence production and whether they executed the whole sequence correctly. If they made a mistake in one, then the whole sequence is considered incorrect already. These indicate the right responses. Same thing here. Set the correct answer, push attribute, and then we do a log. Don't worry about reset bits. Reset bits is resetting the port to 0. And of course, we give the feedback here. This is quite important, in which if there are mistakes, so they do a matching here. This is actually the most important. They do a matching, and if each of this whole portion here, we don't have to worry about it in feedback. This is sending commands to the different devices. But this part is important because if you add a additional position, then that needs to be indicated here as well, because it does a matching based on which key press is correct or wrong, and then it then sends you to whether it shows fault 1, fault 2, fault 3, fault 4 as well, okay, because it kicks in the feedback procedure. And then if f1 equals to 1, you see it was defined here, something was defined here, f1 equals to 1. If it didn't match, then we run fault 1, fault 2, fault 3, fault 4 in a sequential manner. And if all of them are equals to 0, in which is here, then you show the good label, which is that unreferenced object, who, like that. All right, so as I said, this runs a number of different times. When it kicks into a no-go procedure, this is being done, right? So this is very similar to what's above, but it's called QList2, and it's the no-go procedure. And in here, we change one script as well, tech and Q, because it's repeated here, and it captures. So that's being shown. That's being copied over. Fixation, feedback fixation, and if it's a go or if it's a no-go, it's red in color. This is the one for no-go, right? A go, it's blue in color up here, and when this part of it, you know, it runs through the list, this earlier list here, right? If it detects that it needs to do this from an earlier instruction, so out of the random slots, right? It says random selection, right? In here, this is the, you can display the property pages. Sorry, not just the property, but the cycles in here, right? And because it's random selection, right? I wouldn't touch this, to be honest, if I were you, if anyone at all. And once it kicks into a random, and if it picks 2, it picks QList 2 as one of the random, then it will come down into this one and run QList 2 to tell people not to go as well, right? And of course, if they made a mistake, then it goes, there's also feedback in which it tells you whether you are meant to go or no go. All right, so I hope this has been helpful. I would say the most important things, I just want to reiterate again, that the most important things that if you want to change are introducing more trials. So sorry, to come to this point, the 3 most important things, right? If you want to have more sequences, then you need to include, you need to define some things, like for example, the H loop in here. So this would mean there's 4 sequences, right? So you would define another 2 more sequences. So where do you define more sequences? You go into, you just have to look at the fixation script, I think is here, tick and cues. You would have H3 and H4 defined in here, so as to show what it is. But this has to match how many times you want to show the variables as well. So in an earlier one, remember in I think not QList 1, but took some board here. No, set variables. This until loops here, right? So if you have 4, then if you want to show them all correctly, equally, they have to be divisible. All right. You have to match up the numbers in which they're shown. If you have 4 and you divide this by 4, then each of the sequences will be shown 6 times each, basically. Okay, so that's how it works. You need to play around with it and test it a lot to make sure that that's what it is. Now, if you want to increase the number of items in the sequence, if you want to increase it to 8, you add on what are the next 2 as well. In here, in the tag and cues, all right? Then you need to remember to change this as well, that it randomly, the sequentic cues to randomize between 1, 2, 3, and 4 if you have 4 sequences, but also in the queue procedure, right? This has to change as well. In the queue procedure, it's 6 positions and not, it's 8 positions and not 6 positions. But that's if you want to change and increase more sequences or add more positions to it. As it is, I think the whole experiment is very, very fine. I would say do not change anything at all, because you would still find very, very interesting results using 2 sequences and 6 items per sequence. You can vary the number of blocks as well by repeating the blocks. All right. So yeah. Now the last thing is, in this paradigm, we usually at the end of training, let's say we repeat this block 6 times for each of the participants, and then we introduce a test block. And in the test block, we have the 7th block as something different. So new sequences come in. And I'm going to include the test block script as well. But we put in brand new sequences for them so that it sort of confuses them. We want to understand how much of their learning and what it differs when you have a familiar sequence versus an unfamiliar sequence. Is this a way of testing how much learning was going on by comparing the differences in response times and accuracy between these two blocks as well? That's something that you want to think about, but I would recommend that you just run the block 6 times and look at changes in response times and accuracy across the 6 blocks based on these different participants that come into your study. As I said, it could be interesting for you to test dancers versus non-dancers, how quickly they learn, and that could be very, very. You could capture some information about asking them how they learn or what their strategy is when they go into a task like this. Anyway, play around with the script. You can't really go wrong. Save the original file, keep it there, and then any mistakes that you make, you can always have the original in there in terms of your next versions of the file. And good luck with your programming. Thank you and see you later.